Hi guys, welcome back to our digital VLSA channel. Hope you are all good. In this tutorial, we will design a D flip-flop using D-Latches. So before going to this, we will learn about D flip-flop functionality, and we will also learn about its functionality based on timing diagrams. First of all, what is D flip-flop? So D flip-flop is a storage device. It's a 1-bit storage device, and also D flip-flop output always depends on input and active edge of the clock. Okay, what's the meaning of active edge of the clock? Active edge in the sense either the output changes with respect to input either at positive clock or at negative clock. Means positive edge of the clock or negative edge of the clock. What is meant by positive edge of the clock? So this is the signal. Let us assume this as a signal, or let us assume this as a clock. This is positive edge. That means signal going from low to high is called positive edge, and also signal coming from high to low is called negative edge. Okay, so output of the flip-flop triggers or changes with respect to input only at this active edge, either positive or negative. Okay, that is based on our design. If we say to trigger at positive, then it will only change with respect to positive, and remaining all the times the output of the D flip-flop holds its previous output value or retains the same value. So this is the functionality that you should remember in your mind. So first of all, we will look its characteristic table. Let us assume previous state of the present state of the D flip-flop is Qn, and next state is Qn plus 1. Okay. So what are the combinations? 0 0, 0 1, 1 0, and 1 1. So what's the functionality of D flip-flop? When input is 0, output is also 0. Means output is same as input at active edge of the clock. So Qn plus 1 next state output is also same as input. It is not depending on the present state, that you need to observe carefully. And here also, here input is 0, so output is also 0. Input is 1, so output is 1. Input is 1, so output is 1. Here anywhere it is not depending on present state. This is present state. Okay, so by this we can say Qn plus 1 always depends on output only, not on present state. So Qn plus 1 equal to D. So this is the functionality of D flip-flop. Let us see its detailed explanation about D flip-flop by looking at timing diagram. So this is the timing diagram of D flip-flop. So let us consider this as a clock. It is a square wave with some period. Okay, so this is a clock. I am assuming positive edge. So signal going from low to high is called positive edge. So I am assuming I should observe the changes in output only at positive edge. So this is some random input signal I am giving. Let us see the output. Till the first clock edge or before positive edge of the clock, let us assume output as 0. Okay. After positive clock, at the positive clock, not after positive clock, at the positive clock, what is the value of D in? 1. So Q out is also 1. Okay, and it remains same until next positive clock. What's the value of D in here? 0. So the output became 0 because of D in, and also it is at active positive, that is active edge, that is positive clock. So output became 0. and it remains same until next passage clock. Here, what is the value of D in 1? So output became 1. So it remains same until next passage clock. In the next passage clock, what is the D in 1? So output is also 1. So this is the functionality on the timing functionality of D flip flop based on timing diagram. Now D flip flop using D latches. So this is the implementation of D flip flop using D latches. Here, what is meant by D latch? When enable is high, enable equal to 1, output is equal to input. When enable equal to 0, output holds its previous output value. So that is the functionality of D-latch, and also it latch in the sense it is level triggered. It depends on either 1 or 0. Enable input 1 or 0. Whereas flip-flop is not like that. It depends on edges, either positive edge or negative edge. That is the difference between flip-flop and latches. And also we are giving clock, inverted clock input to enable signal of the D-latch one, and the clock signal, direct clock signal to another enable input of D-latch 2. Okay, let us see its functionality based on timing diagram so that we are getting the same D flip-flop output or not. We know how to get D flip-flop output based on clock and D input. Now let us see by using D latches also. So this is the clock. I here also I assumed positive edge of the clock. Now this is D in, some random input signal. Let us see. Let us forget about D latches. Let us see what may be the flip flop output. So when here let us consider this passage. At this passage, what is the D in 1? So Q flip flop became 1. Forget about D latches and everything. Before what we discussed about D flip flop, the same rule applies here. We are now finding D flip flop output. So here 1. It remains same until next passage. In this passage or at this passage, what is the value of D in 0? So it became 0. It remains same until next passage. This is the next passage. What's the value of D in 0? So the Q output also became 0 until next passage it's remained same. What's the value of D in here at this passage? 1. So Q output became 1. So this output we need to get when we implement with D-latches also. So let us see. Now for the first D-latch, Q1 is output, right? This is Q1. So let us see how it came. First, latch in the sense when enable is high, latch becomes active so that Q1 output changes with respect to input, and also output is equal to input when enable is high. Okay, when enable becomes high in this case, when clock is 0. When clock is 0, because of inverter here, enable pin input becomes 1. So when clock is 0, we need to assume enable becomes high so that Q1 is equal to D. So when clock is 0, Q1 should be equal to D. Okay, here see Q1 is equal to D, and it remains same when enable is 0. Here clock is 1. So when it is applied to inverter, it becomes 0. Enable 0 means Q1 retains uh, its previous value. So Q1 is having 1 only until the next clock, until the next stage where clock equal to 0. So again clock became 0 here. Here clock became 0. Now the Q1 should be equal to D. See, now Q1 should be equal to D, right? Uh, this, this this remains same until next clock equal to 0. At this point of time, clock equal to 0 and D in is this equal to this one. So Q became Q is equal to D in here, and then it remains same until next clock equal to 0. Here clock equal to 0, and again Q output Q1 is equal to D. So see, Q1 equal to D, and it remains same until next clock equal to 0. It is not edge triggered. It is depending on the levels, either clock 1 or clock 0. So I hope you understood this. Let me explain again. We need to obtain Q1. We need to obtain Q1. This one we want. When the Q1 value will change when enable is high. When if enable wants to become high, clock should be 0, because clock is applied to inverter and then inverter output is applied to enable. So when clock is 0, enable becomes high, so that Q1 becomes equal to D. Okay, now let us see here. When clock is 0, Q1 Q1 becomes equal to D, this one. Okay, and all the way it remains same irrespective of D. It doesn't depends on D until next clock equal to 0. Here clock equal to 0 again. So the output, this is input, the output, this is output, is same as D until the next clock equal to 0. And then here output is equal to D until next clock equal to 0. And then here output is same as D, right? Until and and it remains same until next clock equal to 0. Now here output is equal to D, because clock is equal to 0 here. So this is about Q1. Now how to obtain Q out? Here for D-Latch 2, Q1 is becoming a input. So Q1 is input to D-Latch 2. So this is assumed as input signal for latch 2. Let us see. And also clock should be high, because enable becomes high when clock equal to 1. So when clock equal to 1, enables becomes 1, and Q output, here Q2 is Q output, becomes equal to Q input, that is Q1. See? And it remains same until next clock equal to 1. Here this is clock equal to 1, and here Q1 is 0, so Q out is also 0, and it should remain same until next clock equal to 1. Now here for this 0, Q input is 0, so output also 0 until next clock equal to 1. Now for this Q input is 1, so Q output became 1. And if you observe finally, this output which we obtained from latches is equal to previous what we observed for the Q flip-flop, I mean output of flip-flop. It is matching, right? I mean the flip-flop behavior is same when it was implemented with latches. So if you observe these two waveforms, those both are same. So this is about D flip-flop using D-Latches. So if you really understood this video, please like, share and subscribe to our digital VLSA channel. Thank you. Bye.